Time for another code review. What's up guys, my name is Cherno. Welcome back to the series where you guys send me your code and projects and other things that I never asked for, and I take a look at them and give my thoughts on them. So today we have a 2D C++ game, Egg 9. I'm not really sure what an Egg 9 is, but perhaps some of you who are a little bit more experienced than me can drop a comment below. lol.io is like the name of this account. I've hidden the email address as I usually do, but that's a fantastic start, strong start. Hello, I've been working on my game engine for about 2,000 hours now, and I really would appreciate it if a professional could review my code. This project is going into my portfolio, so roast me as much as you can. I don't know if you want to ask me to roast you as much as I can. But on the other hand, the thing that I'm immediately thinking about, by the way, if you guys thought I was going to review code today, no. We're going to be reviewing this email today. Roast, along with, I've been working on this for about 2,000 hours. Like, how mean of a person do you think I am? Because I just don't even know if I'm capable of that. It's a bit of a juxtaposition here because this is a lot of work and I don't want to be mean to you about all of your effort. So I'm going to try and be gentle. I'd like you to look at code structure, the way I handle the project of the user, managing the sprites, and how you would sew things. Also, the engine won't work if you don't have the engine, as well as the project in the C directory. Oh, buddy, you won't need a build system or anything, just hit build in VS. That's not necessarily a good thing. But also, the engine won't work if you don't have the engine as well the user project in the C directory? How am I going to be nice about this? This is a strong start. I mean, to be completely fair, this is... I'm just going to apologize in advance. Please try and take any advice and criticism that I give you. And for all of you watching who didn't write this project, because I have a feeling that we're in for a ride. This is like the biggest disclaimer ever. I'm not trying to be malicious. I'm going to try my best to give you helpful and actionable advice that will improve your programming. So let's take a look at this. Okay, so this is the GitHub repository. The link will be in the description below, so if you would like to take a look at it for yourselves, you definitely can do that. Project is a simple 2D game engine using SFML, DIM GUI, and I don't know what this is, Renee? Sure. I actually don't know what that is. It looks like it's got quite a lot of features. I mean, if you put 2,000 hours into it, I expect this is not just a small project. Okay, so let's kind of maybe read this. I'm kind of interested to read this. With these larger projects in general, I feel like I'm not going to be able to look through every line of code. So looking at higher level things like this might actually be more helpful, especially to the broader audience. That's kind of my hope. And that's why I'm focusing on this rather than immediately cloning it and just running through the thousands of lines of code. So the engine calls the only one update and one start method of the game class. I'm guessing this person isn't an English native speaker. I apologize profusely if they are. The engine calls one update and one start method of the game class. If you create a new script, you need to call the update method from the script in the game class. I mean, why? I don't like that. If I'm understanding this correctly, it seems like you need to manually call the update method from the script in the game class. So this is already a bit of a conflict of design here, because if we have a game class that is presumably part of the engine, because it's like the central game runner kind of class, I'm assuming, then the fact that we need to modify the engine code when we do something as simple as creating a script, which is clearly on the game side of things, this is already not a good design, because the core engine should be treating the game scripts as just data, meaning that they are kind of like an asset that the game has. The core should simply load that data, and then in this case with the scripts, simply execute the update function within the scripts. It's the fairly simple concept of just having a core engine and associated data/assets that the core will simply load and then use. So this is already not very good. Now, if you are inspired by these code reviews and you want to improve your programming, then there's an excellent free way you can do that with the sponsor of today's video, Brilliant.org. Brilliant.org is an amazing website filled with lots and lots of excellent high quality courses on various STEM topics, computer science and math, both extremely important for the world of programming, and Brilliant has excellent courses on both of those topics. And their courses specifically, why I love them so much, is because they're extremely visual, engaging, and interactive. They're just honestly a load of fun to get through, and they're not too long or anything. You can just get through them if you have only a little bit of spare time. Their range of math courses is so huge. They've got everything from the entry-level everyday math course, which is a great way to ease into math, all the way to stuff like calculus, which is really useful if you're making games and game engines, but also quite difficult difficult. But taught by Brilliant, it's just become so much easier to learn. Because as you probably noticed from all of this footage, they have these widgets you can play with so you can visually see how things work, and they'll quiz you to make sure that you're retaining and actually remembering, learning the information they're trying to teach you. Now, the best thing about Brilliant is you can get started for free. They have a 30-day free trial that you can use to check out their entire platform and try out some of their courses. And if you do go on to like them, Brilliant have been nice enough to offer the first 200 of you 20% off an annual membership. Huge thank you to Brilliant for sponsoring this video. If you want to share instances, simply pass them in the update method or set a pointer to it in the start method. Instances of what exactly? Scripts? Again, this is involving a lot of you know, modification of the core engine. It's possible that the game class could be game side. I mean, I don't know yet. I haven't looked at the architecture, but it's possible that it could be game side, in which case that might be better, but still not preferable, because the dream situation here, which I'm sure most people would probably realize, is that I simply have scripts, and whatever scripts are part of the game just magically will function and work without having to go into C++ code and start calling them directly as function calls. You can get access to a sprite by calling this config pointer sprite get sprite with name. Okay, this method returns a pointer to the sprite in the sprite repository. Now you're able to do all kinds of things with the sprites. Please note that the engine does still have a lot of bugs. You can start by downloading the engine here. Find introduction to the engine on YouTube. Okay, so there's a full-on like 25-minute introduction video, which is pretty cool. Create a project. In the folder, open the exe and create a new project by clicking on the create button. So the exe is probably some kind of launcher that we saw, that I noticed inside the YouTube video. File dialog will open, select where you, letter U. This isn't texting, mate. If you're writing a README, you should probably write proper words. You want to create the project and hit the plus button. All the files from the template folder will be automatically copied to location. By the way, if you want to hit build or Sturg B, I'm guessing that's control. That rings a bell from like German keyboards. I remember back at the, what does that mean? Yeah, okay, it's German for Steuerung, and is what the quotes, yeah, I remember that. I went to school in Germany for a while. So control B, the engine, the exe will automatically build into a folder. Oh, by the way, there comes the English, not native language, probably. Oh. So you don't need to worry about messing around with resources DLLs. Well, that's good. How do I script my sprites? Right-click the hierarchy window and select new sprite. In the game engine, you can right-click on the asset folder and select new C++ script. So we have a separate sprite and a script at the moment, and this will contain new script containing the update and start functions. Eventually, the script which gets created is out of date. You can find the docs, blah, blah, blah. So you can create a new sprite pointer in your class. So this, again, is kind of very C++-y. We have this game class, which we're manually kind of adding a sprite pointer to. Oh, and then I don't like this design already, and I'll explain why in a minute. I just want to read through the rest of this first. You can give the sprite pointer an address by calling get sprite by name. Give the sprite pointer an address and search for the sprite with the name. This will turn a null pointer with the address to this sprite. So I definitely don't like the way that you are just simply storing memory addresses of sprites inside the game class. Finally, you can change the properties of the sprite using the update function, for example. Okay, so this is, I guess if this is, so what about the script? Does the script not run for the sprite? Is this the script? Looks like it's like a main game class. And then if we hold the A key, then in this case, we can just transform the sprite's position. Sure. How do sprites get managed? All the sprites are getting managed by an object called sprite repository. It contains a private list of sprites. You can add sprites to the scene. Okay, so this doesn't look like an entity component system. We'll look at the diagram here in a minute as well. So here we're seeing a new sprite being created. So game starts and we're creating a new sprite by just calling new sprite. So memory management, there's going to be a lot to talk about there immediately, because this is definitely not optimal or not how I would do things. And then we have inside config, we're accessing pointer sprites, which is some kind of collection of sprites, and we're adding this sprite to it. I'm assuming that's handing off the ownership of the sprite and its allocated memory into this pointer sprites, and it might get released. This is, okay. Oh my gosh, there's so much to say. See, this is the thing about code reviews. I like picking simple projects because I can just complete them within one 40-minute video, and that's kind of it. This, I could come in and give weeks worth of consultancy for, probably, as well as valid strategies for how you would fix this. And more importantly, something I feel may actually be more beneficial to viewers of this video, and a lot of my videos in general, is why this is specifically not very good and how we can improve it in a kind of high level, potentially actionable way that isn't specific to this project. So I'm going to do my best in this video to, again, not be too roasty, even though I was asked to roast as much as I can, and then we'll just end up seeing how far we manage to get with the potential possibility of future videos on this topic. I'm just going to keep reading this, and we'll get back to my thoughts on this in a minute. So it basically adds it to a system that will process the sprite accordingly. We can activate necessary components such as setting collider.exist to true. This is already incorrect pseudocode because you have a pointer, so you can't have a dot here. You'd be using an arrow probably. To have basic collision detection, here's a simple image showing how the sprite repository works. It seems like there's a lot of emphasis on the sprite repository considering it's the only architectural diagram in this README. So I'm going to assume that it is called Sprite Engine, so I'm assuming that this is just the main type of data we have here. So we have an instance of config, which contains a pointer to the sprite repository. The user project contains sprites, and then we have read and write an array of sprites here. This looks like it was made in Paint as well. Like you got the it's like the paint bucket tool was used for the background, but you can see that there's white in between the letters because those areas weren't filled in. And we have an array of sprites here. And then I guess this is the engine, which has an instance of the sprite repository, but also a config has a pointer to the sprite repository. Is the config part of the engine? Okay, and then we do the processing here. We have an array of sprites we read and write here. And then I'm interested to see what this array of sprites is. If it's like a vector, if it's a custom data structure. This must be the equivalent of some sort of entity component system for this particular engine, because sprites seem like you don't create an entity or you don't create a game object, you create a sprite. That is what you do. And then you can assign behavior to that sprite either directly or by creating some form of external script, I imagine, which will contain like an update and a start function that acts on a sprite. So a sprite is the equivalent of an entity as you would typically find in modern game engines with an ECS based system. So what exactly is so bad about this design and why don't I like it? Pointers. Let's talk about the pointer aspect of this. Pointers are things, numbers, integers that simply hold and provide an address of memory, a memory address. And they're interesting because beginners are taught to somewhat avoid them. Intermediate programmers learn to embrace them and they just love using them and they feel like they're real grown-ups who can use pointers now. And so they literally show no fear. And then experts or experienced programmers, for the most part, avoid them. And so it's like this weird bell curve of like how much are pointers used directly, and it's, you know, beginners are here, intermediates are here, and experts are here. Now realistically experts are probably here because pointers are extremely useful, and when you're programming actual memory related things, then of course you're going to use pointers, and you should, but we're not talking about memory systems here. We're talking about objects, you know, instances of classes here that are the fundamental building blocks of our games. For that, you should never use pointers. And I think in this video, this is probably all we'll talk about because I want to explain this properly. If we just take a moment and we think about what a pointer means, we know that it's a memory address. We just talked about that, and you probably know what that is from your own experience, I assume. There's a lot of meaning behind what looks like a fairly simple phrase of creating a sprite pointer variable and then assigning it to a new sprite. The first thing that's happening here with this phrase is we are allocating a block of memory that is going to hold whatever the contents of that sprite class happen to be, all of its members, all of the amount of space that will take up, that will be stored inside a contiguously allocated block of memory, which will exist in a fixed point inside your memory until it is freed or deallocated. We're then assigning it to a variable that is the appropriate type, which is just a sprite pointer. Now you can technically assign it to other things. The real type of new sprite is, in fact, a sprite pointer. There's no doubt about that. But there are classes inside the C++ standard library which can accept a sprite pointer or any kind of pointer as an argument in their constructors. And what that means is that we can take this same block of code, but then assign it to something like a unique pointer or a shared pointer. What that does is it doesn't change the allocation at all. It doesn't change this part of the equation, and I was getting very messy here, but what it is doing is adding extra functionality to what happens with this memory address specifically, such as adding extra code to process it, that might mean that it gets freed at the end of a scope, which would be the case with a unique pointer. So we've really broken this down, but in this case, it's just stored as a sprite pointer. It is then added into what looks like a list of some sort of sprites, of sprite pointers specifically. And so what we have here is a collection of sprite pointers, which we could assume is some sort of vector. So we're dealing with something like this. This over here is a collection that's storing all of these pointers. Now, the interesting thing about this solution is that it's going to work. I've seen much worse. As an example, one thing that is definitely worse, and in fact won't work and will probably end up crashing your game/engine, is if you try and allocate this in place. So one of the optimizations that I see quite a lot is, which fundamentally is in fact an optimization, and like rightly so that people are thinking about it, is, well, it's annoying that you're having to construct this memory over here and then push back a pointer to this block of memory into your collection. Why not just create it directly within the memory that is allocated for the collection? So in other words, if we had a vector of sprites that, let's just say, is this contiguous block of memory over here, instead of us simply storing an 8-byte pointer in all of these cells, so this here is really just a representation of what this would look like in memory, and then each of these is going to point to some completely unique and unrelated block of memory elsewhere. Instead of us doing that, maybe you should just store a sprite in all of these. And a sprite might be bigger than 8 bytes. I don't know how big it is in this engine. It could be like 50 bytes or something, whatever. But the idea is when I iterate through this, that might in fact be an optimization. And iterating through sprites, very, very common, very necessary. I want to render all of these sprites. How am I going to do that? Well, I need to iterate through them. And I'm obviously talking about simpler engines here, such as this one. If you had a more advanced engine, then you might not just have a global collection of sprites. You might have some sort of partitioning system. The design there is going to be more complicated. But in this case, we just have a global list of sprites that is literally stored in like the game class or the config inside the main engine. I mean, this isn't even divided into scenes, which is another thing I was going to talk about. It literally is just a global pool of sprites. So that would be an optimization, because if we go through that vector of sprites inside this for loop, we now no longer have to retrieve the actual sprite pointer from elsewhere in memory, which means that again, our memory reading is being redirected. There's this first part of having to retrieve the vector memory, but then once you're inside the vector, you have to go elsewhere to get the memory for that particular sprite, because if you have pointers, they're all pointing somewhere else. So that part is optimized, because to get that sprite memory, well, it's already here. Each one of these elements is already a sprite. But then what I've seen people do is they still need to access it like this, because they want to make individual changes to the sprite. So what they tend to do is get pointers to the memory inside the vector. And so you can do that in two ways. You can either just actually get a sprite pointer, or you can get a sprite reference. There's no difference between these two. References are just pointers. They just have different semantics when you use them inside C++. And in this case, there is no difference with what I'm about to say. And the way you get that is you can simply ask the vector, hey, give me like element 2, please. And I'm gonna go ahead, and this is probably gonna be very hard to watch because it's diagonal. I apologize for that. You know, give me this sprite, which might be the memory address of that, or if you wanted to use a reference, you know, you'd have a reference just simply like that, and then you might want to store that somewhere and do whatever you want with it. It might be harder to store references, but you can obviously store pointers as if they were normal variables. So what is the issue exactly with that? Because it seems like an optimization, and you might even consider suggesting that to someone who is instead creating individual sprites by using the new keyword and then storing them in a collection, which adds that further layer of indirection. The problem is that this memory is not fixed, which in turn means that these things here, which are just memory addresses, they're not identifiers to sprites. And I think that's really the core underlying issue here. The fact that when you store a sprite reference or a sprite pointer, in fact, any kind of reference or pointer, you are simply storing the address of that data in memory as it stands right now in this moment. Game engines are complicated applications which might, for further optimization or just out of necessity, really, reallocate existing memory somewhere else. So as an example, what if I want to add a 5th sprite here and we don't have room because this is the entirety of that contiguous allocation? Well, we need to find a new block of memory and we need to resize and grow the vector. It is possible that it might be able to do some sort of realloc and simply grow the existing memory whilst keeping the same address, but you're probably going to end up with a completely different block of memory that is now bigger, able to house your extra sprites. What that means is that any reference you had to that sprite, so either an actual literal reference or a pointer, is now completely invalid. It's now pointing to memory that has been freed. You have an invalid pointer, and if you try and access read-write to that memory, you're probably going to crash. In fact, crashing would be the preferable thing here, because the other option might be you're overwriting other memory that you didn't mean to touch, or you're reading garbage. So in actual fact, it's really dangerous to simply take pointers or references to elements inside a vector. And instead, what you should do is anytime you want to use or reference an element within that vector, you should use this directly. Because if you always simply write vector at element 2, you will always get the third element inside the vector without worrying about, oh yeah, but has that vector grown? You know, has it reallocated its internal memory? A detail that you should never care about. Now, if we continue breaking this down and we take a look at what the heck 2 means, because I think that's an important thing to look at. We've solved one problem because we're still doing the thing where we are storing all of the sprites themselves in contiguous memory instead of pointers to additional blocks of memory. So this is still a good thing, but we lose the ability to simply refer to them like this as a sprite pointer, which, by the way, bit of a disclaimer, of course you can still do that with a vector. I'm just saying that you should be careful about it and you probably shouldn't do it too much. In fact, if I was being really pedantic and careful, I wouldn't do it at all, because whilst it might be okay in a scope such as this, if you end up storing that anywhere, it might work for the time being, but then depending on how the vector is used and when your engine grows, it can lead to hard to find bugs. And we've had some of them in my Hazel engine as well, because this doesn't just apply to vectors like these ones. Taking references and pointers in general might be difficult if their underlying memory and storage pool is being modified between you using those pointers or references. So we have made an improvement, but now every time we want that sprite, instead of just being able to store it as a pointer, we now have to use this mysterious number 2. This isn't really great. Now, what we could do though is we could give it a name. This is a very simple programming tactic that we have. If we have a variable, why just write 2 all the time? If I can instead give it some kind of name, such as sprite, and then what does that mean? That means that when I write vector, and instead of writing 2, I now write sprite. So it's kind of cool because it's like I've taken this name, I mean it was SPR here, but I've taken this name and I've given it the value 2, and now I have a way of giving a name to the exact data that I want to access instead of it being arbitrarily 2, and it still works with the rest of the system, which is great. And what have we done, really? Well, we've created some form of an ID, haven't we? We have an integer that defines a particular set of data that we would like to access, which is our sprite, and it will remain here forever. The only reason why it wouldn't is if you delete it, if this vector gets completely deleted, if you move or rearrange the sprites, like as an example, if instead of push back to vector, you were doing push front or something, or if you swap out that index, that element inside the vector specifically, of course you're going to lose the data. But if you just let it exist as is, then of course it's always going to be index 2. It's not going to have the same problem of, well, I was holding a reference or a pointer, but that was a memory address and the memory got reallocated, so now I've lost it. No, you're always going to have a valid ID to that sprite. Now, in more complicated systems, you need to be careful with this, which is why we generally use things called UUIDs, universally unique identifiers, which are the same, well, depending on who you ask and depending on which context you use them, they're basically the same things as globally unique identifiers. And what those are typically could be anything from, in my mind, could be anything from a 64-bit at least, probably, to 128-bit, 256, whatever bit integer that is supposedly globally unique or universally unique, meaning that there's very, very little chance for a conflict if you generate one of these. So as an example, let's just say we have a 64-bit UUID, which is currently what Hazel uses for all of its identifiers. If I randomly generate a number that is obviously, if it's unsigned, 2 to the power of 64 is the range there. So this is kind of the range of numbers that I'm generating, and I'm just randomly gonna come up with a number in that range. very, very unlikely that I'm going to get any kind of conflict. And it means that I don't have a simple ascending index that might not work. Because if you needed to have an identifier that was unique across scenes, this is a very simple case, but let's just say you have two scenes inside your game. You have like even a main menu scene, and then you have the actual game scene. And then you're referring to everything as sprites because, well, you have sprites in all of them. You have some sprites in the main menu, you have some sprites in your game. If you just have an ascending index that just goes 0, 1, 2, 3, 4, then as those two scenes are being built, you're going to run into conflicts. And if you do still maintain a global vector of sprites, as you're doing here, and just whatever, we have multiple scenes, but there's still a global list of sprites, well, what happens if there's someone else on the team working on this project? They're obviously creating new sprites, which means that they're getting an ascending index, index 5, for example, but then what if you also create a new sprite? Then both of you have created sprite number 5, and that's going to be a conflict. But if you randomly generate a 64-bit unsigned integer, they're going to have completely different numbers. I can almost guarantee it. I don't remember what the exact probability of a collision there is generating the exact same number, but maybe someone in the comments wants to point it out. So this is really the preferred way to do this. But at the very least, what I've hopefully shown you is that instead of trying to refer to these sprites as pointers to blocks of memory that are either very fragmented, meaning that every time you add a new sprite, you allocate a block of memory somewhere else inside your RAM, which again, you don't want to do for the sake of how memory works in general and how it's faster to retrieve cached memory, but also you avoid using the memory address as an identifier, which, as we've talked about, is not a good thing to do. And then actually, one critical thing that I probably didn't mention about this, because I wasn't really thinking about using memory as an identifier per se, even though that is kind of what you're doing, is that you can't serialize that, obviously. Like, if you want to save that sprite, you need a way of identifying it that isn't its memory address, because the memory address is going to be different every time you run, and it's not going to make too much sense to do this. But if you just simply have an ID, even something as simple as 2, or better yet, a UUID or a GUID, you're going to end up with a much more powerful way to identify that sprite, which will obviously be persistent globally, and you won't have any problems with that. But at the very least, you could switch to using something like an index, which is going to give you a whole range of benefits. Now, dealing with it as a specific integer, like if you just store integers, there was this example over here where you're storing a sprite. If you just change this to be an int msprite, you might not like that because you lose out on some of the functionality, meaning that you can just do something like msprite.transform.position.x, and that might be something that you like doing, versus if it's just an integer, you having to retrieve the sprite from the vector first like this, and then on this object having to use, well, if it's just a list of sprites like that, you know, dot transform or whatever. But that's not really a problem because you can still create a sprite class. So you have your class called sprite here, but then internally it can have that ID, which is really an index into where it's stored. And then as long as it has some way to reach that vector, so as an example, you might give it some sort of reference to the scene or to your config or to your sprites vector or whatever, then you can still write all of your functions around that. I mean, it would have to be a function. It wouldn't just be dot transform, but inside this sprite class, you could have a function as an example, you know, called transform, which when it's called, would just go into that vector at the index that you have over here, find the sprite, and then give you that transform. And that's what it would return. And then of course you'd return like a reference to it or something. And then you'd have to add like the little parentheses here, but the functionality would kind of more or less be the same. And you could still store sprite here, but the idea is you're not storing a sprite pointer, you're storing a sprite object, which is that identifier. You know, you've kind of wrapped the fundamental underlying identifier that lets you access that particular data with functions that go in and do that accessing for you. And again, all that does is it just gives you a little bit more API design to hopefully make your code look nicer, because you don't have to go into the underlying data structure to retrieve the data that you're interested in reading or writing. As I mentioned earlier, the other huge issue with this is that this is your game class, and then the way you create sprites is you just do new sprite, and you're putting it into the config, which just has a collection of sprites. What about a context for these sprites to exist in? Like some kind of world, a scene is basically what I'm talking about. In pretty much all game engines, and even in like entity component system-based engines, even engines back in the day, everything still revolves around the concept of having a scene or some sort of equivalent where everything lives. So all of your game world lives within a scene, which includes all of the sprites, all of the different entities that might play audio or have some sort of behavior attached to them. They all live within a scene. And that is so important because what it does is it semantically ties the lifetime of these, I don't know, assets or actors or whatever to this scene. And why is that important? Because games typically have more than one scene, and it wouldn't be efficient or even functional to simply store the entire game inside memory at all times. And so if you create all of your essentially entities within a scene, you can simply move from one scene to the next scene, and then all of this just gets dropped immediately like that because the lifetime is tied to the scene, and you can begin loading whatever might belong to this scene. So the fact that, again, you've spent 2,000 hours on an engine, but you don't seem to have the concept of scenes is a little rough, to be honest. I would have expected something like this. And again, it doesn't have to follow, you know, you might be trying to make something a bit more unique. And of course, you are potentially going to have assets that are shared between scenes. So you might need more complicated lifetime models than just simply a scene contains everything and that's it. But that is still something very important. And I would say that these sprites that you're storing here should be contextually residing within some sort of scene. Maybe you could have a scene which owns a list or collection of sprites as an example. Okay, I think I'm gonna stop the video here. Let me know your thoughts about what I was talking about. I hope that this was helpful to some of you as well as the author of this engine. I haven't even opened this engine in Visual Studio. We've been on the GitHub README this entire video, which I honestly did not expect. Before I started the video, I went ahead and cloned the repository so we'd be ready to go, and we didn't even progress past the GitHub README, which is amazing. If you would like to see me continue on with this engine, let me know in the comment section below, as well as if you liked this idea of me drawing stuff and explaining things in a little bit more depth. My hope is that this is more helpful than just me talking and looking at code and giving commentary, so please let me know if you liked this. If you would like me to review a code, go ahead and send it into chernoreview@gmail.com. There will be some instructions in the description of this video. We might be stuck on this project for a while, but it's always good to send in your code because you might be next. Don't forget to check out brilliant.org/thecherno. Link will be in the description below, and I will see you guys next time. Goodbye.